Hello students, welcome back. Let us continue with chapter 7 triangles. We will take a look at exercise 7.3 which is on page 128. Now this exercise is going to be based on all the properties that we learnt about the triangles. That was SAS test of congruency, angles that is side angle side test. Then we had the angle side test, that or AAS or ASA which was angle side angle, or SSS which is side side side. And then finally we had the RHS test which was right angle hypotenuse side test. So based on the properties that we learned, let's take a look at the exercise, that is 7.3. So we have a triangle ABC which is and triangle DBC within it, which are isosceles on the same base, which means that AB is equal to AC and DB is equal to DC. So what all do we need to prove? We need to prove that triangle ABD and triangle ADC are congruent. So let's take a look at these two triangles, ABD and ADC, or ABD and ACD. So ABD and ACD. Should be ACD. So how are we going to prove them congruent? It is very obvious over here. We have been given that AB is equal to AC, DB is equal to DC, as well as this is the common side here. Therefore, the two triangles are congruent by the side test of congruence. Now let's go ahead and write the proof for the first part. So I'll say 1, 1. In triangle ABD and triangle ACD, AB is equal to AC and DB is equal to DC, both are given. Also I have AD as the common side. So AD is equal to AD common side. Therefore, what can I say? The two triangles are congruent by the side test of congruence. Therefore, triangle ABD is equal to triangle ACD by SSS test. So we are done with the first part. Now we need to prove that triangle ABP and triangle ACP are congruent to each other. So which are the two triangles? I have ABP. So these two triangles now, ABP and ACP. So if you notice these two triangles here, we have AB is equal to AC which is given, and you have a common side here. So what else do we need to prove the two triangles congruent? We need at least one angle or one side, but there is no other side that looks equal to each other. We can't really say that BP is equal to PC by any of the given data, or if triangles ABD and ACD are congruent. But I can say that BAP is equal to CAP. Why? Because we have proved ABD is equal to ACD, are congruent. ABD is congruent to triangle ACD. Therefore, ABD is equal to CAD. Why? Corresponding parts of congruent triangles. So I can extend the point D over here and say that BAP is equal to CAP. So now the two triangles, that is ABP and ACP, are congruent by the side angle side test of congruence. Let's go ahead and do this. So in triangle, or rather let's just prove that BAD is equal to CAD first. Triangle ABD is congruent to triangle ACD. Therefore, what do I have? Angle BAD is equal to angle CAD. Why? Corresponding parts of congruent triangles. So now I am extending point D until point P. Therefore, I am going to say, therefore, angle BAC is equal to angle, BAP is equal to angle CAP, and I'll mark this as 1 because we are going to use this as a reference for proving two triangles congruent, ABP and ACP. So now let's go ahead and prove the two triangles congruent. In triangle ABP and triangle ACP, I have AB is equal to AC, which is given. Also, I have the angle BAP is equal to angle CAP from 1. And what else do I have? I have AP is equal to AP. Why? Because it is the common side. Therefore, what can I say? The two triangles are congruent by side angle side test of congruence. ABP is congruent to triangle ACP SAS test. Right? So, my second part is proved. Now, I need to prove that AP bisects angle A and angle D. So, which is my angle A? BAC and BD, and my angle D is BDC. So, what do I need to prove? That BAP is equal to CAP, correct? So, obviously, when we have proved that these two triangles are congruent, that is ABP and ACP are congruent to each other, obviously, I can say that BAP is equal to CAP. First of all, AP bisects angle A and angle D. We have already proved this over here. BAP is equal to CAP and BAD is equal to CAD. So, if I mark this as 2, right, this. So, now what I have to prove in the third part is that AP bisects angle A and angle D. So, now if you want to prove that AP bisects angle A, what do you need to prove? That BAP is equal to CAP. If you notice, we have already have BAP is equal to CAP. So, what I am going to say for the second part, third part, angle BAP is equal to angle CAP, and I'll say from 1. So, BAP and CAP, I hope this looks like P and not D, because P and D can look confusing sometimes, okay. Therefore, now these two angles are equal, then what can we say? Therefore, AP bisects angle A, correct. We also need to prove that AP bisects angle D. So, how are we going to prove that? First of all, in order to prove that AP bisects angle D, what do we need to prove? That BDP is equal to CDP. So, how are you going to prove these two angles equal to each other? Now, if you notice, we have these two triangles here, ABD and ACD equal to each other, correct. Therefore, what can I say? That these sides BP and CP are equal to each other. Why? Corresponding parts of congruent triangles. But which are the angles opposite to these sides? I have angle BDP and angle CDP, correct. Now, these two sides are equal and these are the opposite angles. Therefore, the opposite angles are also going to be equal. So, therefore, we have proved that BDP is equal to CDP, which means that DP bisects angle BDC. So, if I extend my point PD in such a way that D reaches point A. Now, we know that D lies on the line segment AP. Therefore, I can say that AP bisects angle BDC or angle D. Let's write this down. So, what do I have? We have proved that triangle ABP is congruent to triangle ACP. Therefore, what can I say? That BP is equal to CP. Why? Corresponding parts of congruent triangles. Correct? BP is equal to CP. Therefore, angle BDP is equal to angle CDP. Why? Angles opposite equal sides. Correct? Therefore, what can I say? That DP bisects angle D. But D lies on the line segment AP. Therefore, what can I say? But point D lies on AP. Therefore, AP bisects angle D. So, we have proved the third part, which is AP bisects angle A and AP bisects angle D, right? We also need to prove that AP is the perpendicular bisector of BC. So, in order to prove that AP is the perpendicular bisector of BC, we need to prove that AP is perpendicular to BC, and we also need to prove that BP is equal to BC. So, I already have BP is equal to CP over here, correct? I will mark this statement as 2, and we will use this as a reference for proving that AP is the bisector of BC. But first, let us prove that it is AP is perpendicular to BC. So, how are we going to prove that? Let us see the fourth part. Triangle ABP is congruent to triangle ACP. We have proved this, proved above, correct? Therefore, what do we have? Angle APB is equal to angle APC. Why? Corresponding parts of congruent triangles. But if you see, my BC is a straight line and the line AP stands on it. Therefore, angle APB and angle APC make a linear pair. Therefore, angle APB plus angle APC is equal to 180 degrees by the linear pair axiom. So, if I take each of the angles as x, then 2x is going to be 180 degrees, therefore x is going to be 90 degrees, that is 180 degrees divided by 2, which means APB is equal to APC, which is 90 degrees, which means that both the angles are right angles, therefore AP becomes the AP is perpendicular to BC. So, let us write this down. Now, but angle APB is equal to angle APC. Plus angle APC is equal to 180 degrees through the linear pair axiom, correct? I will over here, I will just say let this be equal to x, correct? Therefore, 2x is equal to 180 degrees, which means x is equal to 180 degrees divided by 2, which is equal to 90 degrees. Therefore, what do I have? Therefore, angle APB is equal to angle APC, which is equal to 90 degrees, which means what? That AP is perpendicular to BC, correct? I will mark this statement as 3. Now, we are going to take BP is equal to CP, is equal to CP from 2. Therefore, what can I say? Therefore, AP bisects BC. I will mark this as 4. Therefore, what can I say from 3 and 4? That AP is the perpendicular bisector of BC. Correct? So, let me write this over here. AP is perpendicular bisector of BC. And I will say from 3 and 4. Since we ran out of space, I had to write the answer over there. So, this was about question number 1. It is a little lengthy, but it is very simple. So I hope you have paid attention. It is very important that even if you prove two triangles congruent and you need the reference of corresponding parts of congruent triangles later on, you mention that the two triangles have been proved, just give reference everywhere that the two triangles have been proved congruent, or if some sides or angles are congruent to each other, mark them and use them as reference. Reasoning is very important. I think I have mentioned that in one of my earlier classes as well. Now let's erase the board and proceed to question number 2 quickly. Question number 2 is very small and simple. You will see that. So, first of all, we have not been given the diagram, so we will have to draw this. So, ABC is an isosceles triangle with AB is equal to AC. Let us draw this first. So, I have A, B, C is an isosceles triangle with AB is equal to AC. AD is the altitude and D lies on BC. So, this is my point D. Obviously, both these angles ADB and ADC are 90 degrees. I need to prove that AD bisects BC. So, AD bisects BC, which means I have to prove that BD is equal to CD. I have marked it with a different colored chalk because we have to prove this. Also, I need to prove that AD bisects angle A. So, AD bisects angle A, that means I need to prove that these two angles here are equal to each other. So, first of all, to prove these, we need to first prove that the two triangles, that is ABD and ACD, are congruent to each other. So, how are we going to prove them congruent? If you notice, AB is equal to AC, which is given. These are also the hypotenuse, right, because they are opposite the right angles. Also, we have a common side over here. Therefore, the two triangles ABD and ACD are congruent to each other by the RHS test of congruence, which is nothing but the right angle hypotenuse side test of congruence. Therefore, we can obviously say that BD is equal to BC. Why? By corresponding parts of congruent triangles. Therefore, AD bisects BC, and I can also say that BAD is equal to CAD, corresponding parts of congruent triangles. That means AD bisects angle A. Simple. Let us go ahead and solve this now. So, my proof, AD is the altitude which means that therefore AD is perpendicular to BC. What does altitude means? Altitude means the perpendicular height, right? So, AD is perpendicular to BC. Therefore, angle ADB is equal to angle ADC, which is equal to 90 degrees. Correct? Now, let us go ahead and prove the two triangles congruent. So, I will say in triangle ADB and triangle ADC, I have hypotenuse. So, I am just writing hypo for hypotenuse. Hypotenuse AB is equal to hypotenuse AC. Correct? Because this is already given. But why am I specifically mentioning hypotenuse? Because we are going to prove these two triangles congruent by the RHS test of congruence. Also, I have AD is equal to AD, common side, and I have, if I mark this statement as 1, I can say angle ADB is equal to angle ADC, which is equal to 90 degrees, and I will say from 1. So, this is the two triangles are congruent, that is triangle ADB is congruent to triangle ADC by RHS test. Therefore, what can I say? That BD is equal to CD. Why? Corresponding parts of congruent triangles, which means that D is the midpoint of BC. But we have a straight line here, AD, correct? But D is joined with point A to form line AD. Therefore, AD becomes the bisector of side BC. Therefore, AD bisects BC. Correct? So, this was one part. Again, I will say triangle. So, this is one part and my second part for proving the two angles congruent, that is AD bisects angle A. That means BAD is equal to CAD, right? So, I will say triangle ADB is congruent to triangle ADC, correct? Therefore, what do I have? BAD, that's angle BAD, is equal to angle CAD. Why? Corresponding parts of congruent triangles, correct? So, what does this imply? That AD bisects angle A. So, both of these are proved. AD bisects BC and AD bisects angle A. So, these were the first two questions of exercise 7.3. Let's take a look at the remaining exercise in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.